Okay. Let's have to get to the class. Okay, this week we're going to be taking a look at chapter 9 out of the Think Java book. Next week there will be no class synchronous session, but I will record a video and put it out there. Um, we got next Friday off, Good Friday. Um, Never have had it off before, but since they canceled spring break, then they give us that day off. So okay, strings and things. We're gonna take a look at these different parts here. Let's talk about characters here. So let's come over and get a project going. And let's see, file, new project, Java with Maven, Java application, strings and things. And expand that. Right click on that, choose new, JFrame form. Not that I can remember how to do it, but if I go to the source here, um, got a lot of different items here. Some of this is generated code. And so this is how they do all that, how they build that beginning piece. If I drop I may try it just for fun. We'll see. Um, might have different definitions of fun. And button, there it is. And let me throw three text fields on there from my answers. Okay, right click on that, edit text, backspace enter, resize. Right click on this, edit text. This will be my string. And right click on this, edit text. I'll call this run. Okay, highlight them, make them bigger. There we go. That'll work. Now, I like efficiency. All that could have been accomplished through writing it all from scratch. So, for example, and like I say, I don't know if NetBeans throws any additional in here that you need other files. So this may not work. It's been so long since I wrote everything completely from scratch. But if you went over to a notepad and you wrote all this in here, and save as, go to temp2. Actually, we need to create a temp3. And call this new jframe.java. I didn't do that right. Save as. Change it to all files. I guess it did save. Okay. So I got that there. Now, if my pathing was correct, which it probably isn't, and I never worry about that because NetBeans. Java C for Java compiler, new jframe.java. Where's Java? Java development kit. Bin Java C. There it is. Bin Java C in new jframe dot Java. Program is not. You're just gonna cause me all kinds of headaches, aren't you? Java C C:/temp temp3 new jframe.java. I think dash O for out. Like I say, this may not be successful. What's the extension on it? Boy, it's been so long. Java command line Windows example. Java C. I think it throws a dot out on the end of it. Dash D. So Java C dash D C:/temp3 and then new jframe.java. File I found. Java. Obviously, don't have the right syntax, but the idea would be that you can write a notepad and you can issue that command if I were to get it right. Oh, I see what I did wrong, I think. That looks better. Change directory to tmp3. Change directory to C:/tmp3. That's interesting. Kali directory. Okay, now how do you run it? That's a big part then. Java running dot class file. Compile Java. Let's see. Java C. We just did that. That's Java compile. Then you do Java class name. Okay. Well, Java, and then my class name. I don't know if I need to put class on it, but JFrame. It is not gonna let me do this very easily. There it is. Java and C:/TMP3 new JFrame. Go to main class. Okay, that's probably because it has some dependencies. But if I were to create it completely from scratch, you wouldn't see a program run then. It's time consuming. I took Java 15, 16 years ago at Wichita State. They had us do it completely from Notepad. So it was hard. This is much easier. It takes the drudgery out of it, and you can focus on the programming side. Okay, so now let's go to the run here, choose events, mouse. Well, actually, I didn't name these, did I? Change variable name tf_string. This one I'll change variable name tf_string1. And change variable name tf_string2. tf_string3. Okay, now I'll go to the events, mouse click. String main string. String 1. String 2, string 3. Main string is equal to tf underscore string dot get text. So that returns a string and puts it in the main string. Now let's just print that out just so we can see it. tf underscore string1 dot set text. So we've been working with strings for every program we've written. We had to. There we go. And Dave, click run. Okay, nothing exciting on that. Now here, when you got a string, it's really an array of characters. And so when you do fruit.character at 0, this is referring to the first letter. So this is referring to the B in banana. So if I come over here and I'm going to hard code this now that we've seen that, just so we see what to work with. Equals David Hayes. This is the first position, which is our 0 index. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it always starts at the index of 0. I'll do character C, character single letter, A, B, C, 5, beginning parentheses, so some kind of character. Now, if I did C is equal to, and the character at, you have to put your string name first, and then dot. So what do I got? Main string dot character at 0 should return D. Now, if I try to write that directly, let's see what happens. I don't know if it'll work myself. I'm just wondering. Now, see, it says C. It's because this is a character. Well, they provide us this string.value of, and I think it'll work. String.value of pretty much converts about anything to a string. So then you can write it out. We saw I've been seeing that with numbers. So if I run that, and it gives me D. Actually, I guess I don't need to put anything in that, but it's hard coded. Because otherwise it'll might blow up when. It shouldn't blow up. It brings in an empty string. Okay, never mind. I won't do that then. But that's the character at. You can combine this with other constructs we looked at. So you could loop through. Now, we're going to see how to refer to the length later on. But if I just do a for loop for int x equals 0, continue while x is less than. Now there's 9 there. So if I say less than 10, that goes 0 to 9, because there's 9 is the ending index. Then x plus plus, and here maybe I'll count how many A's there are. That's an integer. Count A. So here I'll do a check if main string dot character at, and then the x position is equal to an A. Then I'm going to increase count by 1. You can do a count plus plus, or count is equal to count A equals count A plus 1. Either way. So then down here, I'm going to write out count A. And there's 2 A's in there, so it should come back and tell us 2. Those 2. So character at may not seem like, well, what would you do with that? What good is it to pick the B off of banana? But if you're trying to go through and count how many vowels there were for whatever reason, you can use that. If you want to do a word count, assuming words are separated by spaces and periods, then you can go through and count how many periods and how many spaces there are, and take into account, how do you handle if you got a period and then a space? Is that 2 there, or if they're right next to each other, then you have to consider that. When you go on Microsoft Word and it tells you the word count, it's not doing anything special in more special there than just counting what I just indicated. Okay. You can loop through your characters like this: A through Z, uppercase A through uppercase Z, C++. And you might look at that and say, well, a character, I thought you said that was a single letter. Why are we doing a plus plus on it? Well, the website ASCIItable.com. For programming purposes, we consider a character the same as a number. So uppercase A is 65 in decimal, and uppercase Z is 90 in decimal. So this is looping through from 65 to 90. So that'd be equivalent to saying that we start out at 65, continue as less than or equal to 90, and then we're adding 1. So that's the direct connection between characters in the ASCII table and numbers. Okay. Here for Unicode, I guess it's unicode.org. But if you went there, you can, you see here we got integer I equals 913, and then we're doing a character inside of parentheses before. What that is that's the casting operation. That's converting our integer to a character. And it's going off of Unicode, unicode.org. A lot you can do with Unicode. So it looks like if you want to do this smiley face here, you can use Unicode. So it's a lot more than an ASCII table. It appears like something missing though. How would you know the corresponding decimal with this? I haven't really used Unicode very much. Emoji. $11,310. $11,310. $11,310. Come down here and I do a cast operation to change it to a character. I never have done this. I was just curious. That doesn't look like that. Maybe I put into a special component. That sure doesn't look like whatever we had over here. This weird thing here. Okay. Strings are immutable, means you can't change them. Now that's a little bit confusing. So we got string name is equal to Alan Turing, and then they use a 2 uppercase. So I got my main string there, and main string is equal to main string dot two uppercase like that. And then I write out main string. And it prints David Hayes uppercase. So you might sit there and say, well, I thought you said immutable means it can't change it. It can't. Um, how this works is this assigns in memory David Hayes. And it makes association between that memory location and then main string. So whenever I refer to main string, it knows where to go look. This redefines the memory location. It's still got the connection to main string, but then this gives it might put it in a different location, for example. So it's not actually changing the existing. It's just kind of redefining it. And that's what they're talking about here. These methods are often source of confusion, but it sounds like they modify the strings. But neither of these methods nor any others can change a string because strings are immutable. You see down here, there's a replace. So we're going to do some different functions here. Now we start doing a replace, and there's different options here. So you can choose these, and these tell you what needs to be passed in for parameters. In this case, this is easier to look at. It's the old string replaced with the new string. So maybe I want to replace David with Dave. If you're writing a program to go through and to do a replacement, then that's something there. What have I done wrong? Restricted semicolon. Unclosed character literal. Oh, double quotes. What am I doing? Single quote is like a character. Okay. So if I run that then, see, replace David with Dave. So you could write this. You could write a replace feature where you have a box pop up and they say, what do you want to replace? And they type it in there. In another box, you type, what do they want to replace it with? And then it goes through and searches through all the text and does all the replaces. Let's do this. See, it didn't work. Didn't give us an error, which I'm surprised about. When you're doing one of these and you've never used it before, or you don't remember it, I don't remember replace. I use it once a year. I teach this class. Actually, I guess I teach it twice a year. But if I start typing replace, if you scroll down here, this first item tells you what's returned. So this returns a string. That returns a string, string, string. So they all return a string. Now, if it said void, that means that nothing's returned. Here returns a string. Character F. Excuse me. Notice it returns a character. So those are very important to help you figure out how to use these. So if you're sitting there and you Google it, you can't really find a good example. Examples on Google are priceless, by the way. But if you can't find a good example, then that will direct you to it. Okay. String traversal, we looked at that where you can go through them a character at a time. This talks about how you can reverse a string. That's fairly easy to do. If I want to reverse David Hayes, by the way, you see there's a length. Now look what it says. Returns a length of the string. So I don't have to hard code that number if I didn't want to. This will return 10 since there's 10 characters total. And notice the public int. The int implies that it returns an integer. And the length, see how there's no parameter to pass in. Okay, so we're going to use that. For int so I can program correctly. X equals 0. No, x equals main string dot length minus 1. I want to continue while x is greater than or equal to 0, I think. And then I want to do x minus minus. This is a method, so it needs parentheses on it like that. Now what this is going to start out with is this going to start out with my last character. Now the reason why I do a minus 1 is the length is 10, so it's 10 total. 10 minus 1 is 9, so that would give me my 9. And then each time through the loop, it'll subtract 1 from it. So 9 minus 1 is 8, 7, 6, 5, so forth. And I want to continue while x is greater than or equal to 0. Okay. So now I want to build a new string. I guess I could use string 1. String 1 is equal to an empty string. And then I'm going to say string 1 is equal to string 1 plus main string dot character at. Now this is going to return a character. I'm trying to concatenate it with a string. They may not be compatible. They'll tell us here shortly. Looks like they are. I wasn't sure what it would do. I was thinking I was going to have to do a string value of here, but of course the key part will be whether it actually works or not. So now I want to write out my new string, string 1, which should be my 1 reversed. Lots you can do with strings. There are also some of the most complex things you'll work with. And there's David Hayes backwards. Substrings. This is how you can pick off parts of your string. For example, if I have David.Hayes and then 100. So I got that. And I want to pick off part of that string. Now, substring returns a new string, copies text from an existing string starting at the given index. So it starts at 0, and that returns everything from 0 on, which is the entire string. And then 2 returns from my position 2, which remember it starts with 0, 0, 1, 2, and then goes and so forth. Well, that'd be kind of a challenge to use. So instead, the substring is overloaded, which means it uses the same name but different parameters. And this is your starting position, and this is 1 greater than your ending position, which means if I want to come up here and get my first name, and again, having these underneath are invaluable, at least until you get it set up correctly. If I want to do string 1 is going to be my first name. So this is going to be main string. Now again, the first position is where we're starting, and this is 1 greater. Oops. Dot substring starts at position 0. David ends at position 4, so I won't go 1 greater. 75. String 2 is equal to main string dot substring. The last name starts at position 6, goes 1 greater, which is 10. Because it ends at position 9, so it goes 1 greater. String 3 is equal to main string dot substring. And the number starts at position 11 and ends at 13, so I got 1 greater, 14. And tf underscore string 2 dot set text string dot value of string 2 tf underscore string 3 dot set text string dot value of string 3. I don't think I hardly ever use where you just put a single parameter in like those first examples. It's always or like a range is what I work with. Although we use that in combination with something else. And yeah, that separates it. Now CSV with commas between them, comma separated values, that's oftentimes a popular format coming from Excel. So we're going to eventually be taking this concept and we'll bring in like a spreadsheet from Excel and we'll separate the data out. Now there's other ways of separating it more efficient, but that shows splitting the string apart. The index of. This returns where the position of something. So let's say that this is our input, but I could have something else come in. Bill Hill. There we go, 200. Let's say instead of David, comma Hayes, comma 100 comes in, we have Bill, comma Hill, comma 200 come in. No wonder is our hard coding a viable option because it can come in different formats. The key is that there's commas between them. So what we're going to do is we're going to search for the position of our first comma. So let me come up here and declare some variables. int comma 1, comma 2. comma 1 is going to equal to main string dot index of. Now notice how there's four definitions here. This is the overloading I was talking about earlier. It means that there's different ways you can call index of. You can simply call it by passing in the string, and then it just finds the first occurrence. What's this one do? Returns index of the string of the first character occurs. Okay. This is one we're going to use after we do our first one, is because this tells it where to start searching from. So let me do index of, and I'm searching for a comma. Now what this will return for my David Hayes will return position. Where's my comma at? Comma's at 5. If I look at this, this is at position 5. So that returned position 5. So now here, instead of hard coding 5, I can put that return 5, so I can put comma 1 here. Now this one starts at 6, which is 1 greater than 5. So this would be comma 1 plus 1. So now I've no longer hard coded the position. I did hard code 0, that's where it starts. But I didn't hard code position. This will search, find the position of the comma, and then adjust it. Now this 10 and 11 are based upon the position of the second comma. This right here is at position 10. So let's find our second comma. Comma 2 is equal to main string dot index of, and then my second comma. Now the problem here is this will return position 5, because if you just pass in a single string like that, it'll always look for the first one. That's not what we want. We want it to find the second one. So that's where this has another parameter where you can tell it where to start searching at. And I want it to start searching at comma 1 plus 1. So it's going to start searching at comma 1. We said it was at position 5. 5 plus 1 is 6. So it comes up here to position 6, which is the H, and then finds the next comma after that. And this should return, for our example here, should return 10. This is what I encourage you. When you work with strings, write down numbers like you've seen me do. Write down an example. Hard code the example. Get your code working and think about how it works. If you asked me to sit down and write this without doing this, I would struggle. It's just like, oh, what do I put here? So we said position 10 was our comma 2, so I'll put a comma 2 here. 11. Well, that looks like 1 greater than 10, so comma 2 plus 1. Okay, now I don't want to hard code 14 because my string could end at different places. You know, this one ends at position 12, and 1 greater than that is 13. This one ends at position 13, 1 greater than that is 14. So instead of putting the 14 there, I want the length. Okay, now let me think this through. Goes up to 13 here. 0 to 13 means it's the length of 14. So instead of putting 14 in here, I can put the length. So main string dot length. That was interesting. I don't have to have length, unless it just knows better than me. Now let's run this, and it should still work. So it works. Okay, no big surprise there. But now let's comment that out and uncomment this and see if this works. Different number of characters for the first name. And that works. And it doesn't matter how long our string is. Bill, Hammer, Stein, Hayes. Assuming that's not too big for an integer. You see it separated. Excuse me. I guess I didn't write that to an integer. I wrote that to a string, so it doesn't matter how big that is. Okay. Now we still got more we're going to cover, but I want you to have the user input a date and a time in two separate text fields. For example, they'll enter in 10/30/2021. That'll be what the input for the date. And I want you to split the month, day, and year apart. So it should print, you should have a text field that says 10, you should have another one that says 30, another one says 2021. The key is, though, you don't want to hard code those values because I could type in this. And it should put a 3 here, 7 here, 21 here. So you'll use the same principles of which we just did, very, very minor changes there, and split that apart. Now for the time, they'll enter in like 10/30 for their time. I want you to split that apart. Split the hour from the minute, and you would have hour 10, and you'd have minutes 30. So nothing too exciting on that. Okay. Back to her. Okay. Now here, it doesn't equals, but maybe you get the wrong answer. There's a string method for strings called dot equals. This is how you can compare two strings, see if they're the same. I come over here and string 1 equals to David. String 2 equals to David. If string 1 dot equals, you see there's only one definition there. So this is not overloaded. There's only one way to call this. You pass in an object. And I'll pass in string 2. And string 3 dot set. String 3 equals same. Now if we run this. I didn't expect it to blow up. That's unique. Um, what in the world did I do wrong? Let's see. I should have returned a Boolean. Hmm, dot equals. String 3 might not have been initialized. Oh, helps to actually read. Told me exactly what the problem was. Okay. Didn't write same. It's interesting. They look the same. Remember me showing the ASCII table? Not sure if I still have that up and running. Big A is decimal 65. Little a is decimal 97. Although they're the same in our view, they're not the same programming wise. So something to keep in mind. If you are trying to compare two strings and one person uppercase is D and one person lowercase is D, it will not match. They will not be equal. Well, you can get around that. String one is equal to string one dot. It's either two upper or uppercase. I don't remember. Two upper. You can make them both uppercase. What did I just do? I don't know what I just did. There. Okay. Now if I run it. It says they're the same because I've made them both uppercase. I made that mistake. Some of you have heard that story over and over. You get tired of hearing it. But I made that mistake on my first real database application. I was asking for the state, but I never considered case. I never considered restricting them down. And people put all kinds of variations of states in there. So you really have to think about your input and trying to make sure it's consistent. Anyway, that's a dot equals. What's a compare to? I don't really use that one. If the string is different, we can use compare to see which comes first in alphabetical order. Okay. String formatting. If you got a way you want to format it, you do string dot format. Now it actually is string. So this is not your variable name. That actually says the word string. And then here you put in some kind of code to tell what it's going to be. Well, the code I'm referring to is D, for example, is decimal integer. The 02 that's in front of it means it's going to be 2 characters long. So if I pass in a 5, for example, for hour, it'll put 05. If I pass in a 12, it'll put 12. Minute is %02D. The D is a decimal integer again, and the 0.02 means it's going to take up 2 spaces. Well, I don't know if it puts zeros in there or not. I think it does. I think that's what the 0 in front does. Let's see if I'm lying. 2-digit integer padded with zeros. Yeah, if you just did a %D or %2D, then it would allocate 2 spaces, but it would have a space and then a number. But by putting a 0 there, that's what puts a 0 in front of the 7, like that. So I'm not very good with doubles on those, I have to be honest. Let me create a double. Double D equals 3.12. Int I equals 7. Okay, so string 1 is equal to string dot format, and I'm going to have a percent 5. How about 05.2 and a percent 2D. Pass in D and I like that. Usually I have to play with those to get them right. And I obviously got something wrong. Might not have been initialized. Okay, string 2 equals to empty. String 3 equals empty. Still got something wrong. What's wrong here? Malform string unknown 0. I was pretty sure they had 0 in the example. Well, I got a lot of these codes still running. Maybe I'm looking at it wrong. Percent 02D. Got percents in front of them? Yeah, percents are in front of them. How bizarre. Fine, I'll get rid of them. Let's see if it likes that. Picky program. So it doesn't like something. Oh, F. What am I doing? Wake up, David. Zeros had nothing to do with it. F is a floating point double number with decimals. Okay. So my first one was, what was my first one? 5. So I had a 5 there. And I put a 0 specifier in front of it, which means it's going to be a 5 in length, and it puts zeros to make up the 5. The dot 2 means I have 2 decimal places. And this percent 02 specifies two positions, and I put a 0 there. Anyway, that's a string format. Wrapper classes, command line arguments. We're out of time. I'm gonna look through to see if I can find a project out of there to go with our the first project I gave you. But we'll stop there. Next week, again, we won't be having a synchronous learning session, the class. Friday's Good Friday, and the college is closed. But I will record a lecture before then, put it out there. So you still have Just have work for the week, but it won't be delivered on Friday. So, but we'll go ahead and stop there.